Hi everyone, and welcome to our next video. In this video we're going to take a look at Kirchhoff's voltage law and take a look at a few examples that you're going to find in your workbook and some that you might find on a quiz or a test. So let's take a look here. So example number 1, it says use KVL to find the current in the circuit below. What it's giving us is the value of R1, which is 20 ohms, R2 is 50 ohms, and VDC, which is the voltage of the power source, is 140 volts. So we know by looking at it that it is a series circuit. So we could figure out that the total resistance is equal to R1 plus R2. So our total is 20 ohms plus 50 ohms, which is 70 ohms. So the amount of resistance in this series circuit is 70 ohms. I can figure out the current now, which in this case, there is only one current, that's the total current, is equal to the voltage divided by the total resistance. So if the voltage of the power source is 140 volts, and divide that by the resistance in the circuit, which is 70 ohms, 140 volts divided by 70 ohms gives us 2, and we know that current is measured in amps. So for this circuit here, we know that we've got 2 amps of current flowing in this circuit here. The equation for KVL for this example is, well, I know that the voltage provided by the source is equal to the voltage drop across R1, which is represented by V1, plus the voltage drop across R2, which is represented by V2. So that would be the equation for KVL in this example here. If we take a look at the next example, let's just scroll up here and take a look. So for this one here, it says use KVL to find R2 in the circuit below given the following information. So we know that R1 is 12 ohms. We know A1 is 5 amps. Well, if you look at A1, this is a series circuit, so the current is the same anywhere in the circuit. The voltage of the power source is 150 volts. So since I know R1 and I know A1, well, that tells me that I know the resistance and I know the current. So I could use Ohm's law and say that V1 is equal to I times R1. Now I could put I1, but really the current's the same throughout, so I'll just put I. So I know that that's 5 amps. And I know that the resistance is 12 ohms. So multiplying those together, 5 times 12 gives you 60, and I know that that's 60 volts. So that I know across V1, this is a 60 volt drop. Well, since I know that VDC is 150 volts, that's the voltage of the source, I also know that VDC is equal to V1 plus V2. Well, if this is 150 volts, and I know that V1 is 60 volts, I could figure out V2. So V2 is equal to, well, subtract 60 from both sides, solve the equation, and V2 must be equal to 90 volts. Now the question says find R2, so actually I still have to keep going here to find the resistance R2. R2 is equal to V2 over the current. So I know that that's 90 volts over the current, which is 5 amps. And if I can squeeze the answer in here, 90 divided by 5 is 18. So I know that that must be 18 ohms. So it wants us to find this right here. So I know that that must be 18 ohms. The equation for KVL in this example is VDC is equal to V1 plus V2. So that's it for this example. Take a look at the ones in the workbook and try those ones. If you have any questions, come and see me. Like I said, you might see this on an upcoming quiz or test. That's it for this video. We'll see you next time.